Hello, and welcome to this FlipRobot e-learning module. This module will look at the case robotic curriculum for FlipRobot and the methodology used to create it. In this module, we'll cover the following topics. We will explain the model used for the creation of the case robotic curriculum, provide information on the various learning and thinking methods utilized from the curriculum, explain the 30-40-30 principle in lesson design, and explain the Assure methodology used to create the case robotic curriculum. By the end of this module, you will have learned to understand the different learnings involved in the case robotic curriculum, understand the 30-40-30 principle, to understand the Assure methodology, and develop ideas on how to implement the FlipRobot curriculum in your body of work. The case robotic curriculum, developed by the California Association for STEAM Education, lies at the center of the FlipRobot solution. Based around clear learning outcomes, it has been devised to provide students with a comprehensive and hands-on STEAM learning experience. The lessons for the starter kit as well as the extension kits are all mapped to ACARA standards to ensure the outcomes are relevant for students. The case robotic curriculum uses real-world applications of robotics at the core of the learning. This is to ensure that all learning outcomes derived from the curriculum can be placed in the real world. This ranges from a class discussion about the potential of driverless cars in Topic 1, through to the physical applications of home automation with the smart vacuum in Topic 6. By grounding the learning in actual real-world technologies, students can clearly understand how what they are learning about in these lessons will serve them in the future workforce. There are two key principles involved in the development of the case robotic curriculum. These are the Assure methodology, which is used to develop the structure of the case robotic curriculum, and the 30-40-30 principle, which was used to design the structure of the units for the case robotic curriculum. We will now look at both of these in more detail, starting with the Assure methodology. The Assure methodology is an instructional systems design process that was modified to be used by teachers in the classroom. The purpose behind the methodology is to ensure the most effective means, technology, and delivery are used for the audience of your learning. We will now run through each step of the Assure methodology. The first step in the Assure process is to analyze the users of your learning. For any effective in-class solution, we need to know who we are looking to teach so we know the best means of ensuring the learning is received. This can include identifying things such as general attributes like age and gender, any prior competencies the students may have in that area, as well as any learning styles that are effective for the audience, such as auditory, visual, or tactile. Once your audience has been identified, the next step is to state the standards and objectives you want your students to get out of the lessons. This is to assist in identifying what you would like the students to be able to do after the course of the lessons. To establish this, a good guideline is to use the ABCDs of learning objective planning. The A being the audience, which we have already looked at, the B being the behavior you wish the students to demonstrate, the C being the conditions which the behavior will be observed in, and the D being the degree the knowledge or skill will be mastered. Addressing these four key areas will assist in creating clear standards and objectives for your lessons. Now that we know our audience and the standards we want to achieve from our lessons, the next step is to select the strategies, technology, media, and materials to deliver the lesson. There are quite a few factors that can impact this decision, varying from the subject matter being taught to how much of the lesson is teacher-centric as opposed to student-centric. Referring to your statement is always a good way to make a decision on this. As an example from the case robotic curriculum, the need for there to be a heavy practical element in these lessons led to the construction of the FlipRobot hardware and the FlipCode coding environment. Having decided on the technology and media to be used, we can now look to utilize them in our lessons. To ensure an effective implementation, it is important to preview the technology, prepare the learning environment, prepare the learners, and prepare the learning experience. This preparation will ensure you get the most out of the selected technology and media to be used in class. The preparation for the lessons is done, and we are now ready to gain feedback from learners on the technology and media chosen for these lessons. The key to this step is effective communication with the learners to find out what is working and what is not. Including class discussions at the end of units of work is a great way to be able to get feedback on how effective the technology was in relation to the learning outcomes. The final step is to evaluate and revise the lesson based on the feedback received in class. It is always good to keep lesson structures organic and being able to amend and improve when required. A couple of good questions to ask when evaluating your lessons are: did the lesson meet the learning objectives planned? How will you determine whether students reach the objectives? Was your choice of materials a good one? Is it possible that other technologies could do a better job? From here, previous steps of the Assure process can be revisited to improve the lessons. This is the methodology behind the structure of the Case Robotic curriculum implementation. We will now look at how the units were created. We will now look at the 30-40-30 principle, which was used to create the units for the Case Robotic curriculum. Here you can see a breakdown to the unit structure under the 30-40-30 principle. As you can see, what the 30-40-30 refers to is the ratio percentage of the unit dedicated to these three areas. We will now look at each section in depth to discover its purpose and what is comprised within it. The first 30% of the units for the Case Robotic curriculum are designed to provide a context introduction and impart subject knowledge to students. This allows students to gain an understanding of the world behind robotics before themselves getting involved in construction and coding. During this portion of the unit, students will be encouraged to use contextual thinking when approaching real-world robotic questions, like driverless cars, and utilizing problem-based learning to find solutions to these questions. Once the subject has been introduced, the middle 40% of the lesson is used to begin the practical applications of robotics. This can include the construction of the robot, physical coding activities, and group coding challenges. The physical interaction with FlipRobot engages students with computational thinking, with the need to think logically about how codes are written, which will lead to exploratory learning where students can grow their knowledge of coding through individual exploration and research. The final 30% of the unit involves summative assessments where students will now demonstrate what they have learned. This takes the form of both practical and theoretical assessments to ensure that not only has the how of robotics been explained, but also the why. The result of both the Assure methodology and the 30-40-30 principle is our program design for the Case Robotic curriculum. It is here where you can see the breakdown of the units and the outlines of the varying practical and theoretical elements of the lessons. The program design for our Case Robotic curriculum is available on the FlipCloud portal, and if you require any further curriculum materials, we also have several curriculum examples on our knowledge base section of FlipCloud to provide some more inspiration. We have now reached the end of the module. By completing this module, you will have learned to understand the different learnings involved in the Case Robotic curriculum, to understand the 30-40-30 principle, to understand the Assure methodology, and provided some ideas on how to implement the FlipRobot curriculum in your classroom. This concludes the module. Feel free to review any previous slides or end by closing the course.